Good morning students. Yesterday we have done about the topic work. Work is a product of the force and displacement. Now today we are considering the next topic, that is what are the conditions of the work. Now there are two conditions of the work. The first, the formula of the work, it is force and displacement. So the formula itself, it tells us that work is only said to be done when the force is applied and the displacement is there. So the force should be applied on the body for the work and the body should be displaced. So out of these two, if any one thing it is missing, the work done will be considered as zero. Okay, so what we can say, that the work is said to be done when an object comes to the rest, an object and moving object come to the rest. Okay, an object at rest starts moving and the shape of the object changes. So when the work is applied, these three conditions can happen, and the work, it depends upon the two conditions, that is, it is the product of the force and displacement. So what is the minimum condition? Then object should be applied. When the force is applied on an object, it produces displacement, and when it produces displacement, then only the work is said to be done. Okay, now next we are doing the numerical based on the work. It is a product of the force and displacement. On this relationship we are going to do some numerical problem. Okay, now it is written a force of 5 Newton. Okay, what is the force? It is 5 Newton is acting on an object. It means the force applied on the object, it is 5 Newton. The object is displaced through 2 meter in the direction of the force. Now due to the application of this force 5 Newton, the object is moving through 2 meter in the direction of the force. So what you have to calculate? The work done. Okay, now this is a very simple and the basic question. As we know that the formula of the W, it is F into S. First, if we see the given condition, how much force is applied? 5 Newton. And due to the application of this 5 Newton, how much displacement is produced? It is 2 meter. Okay, so when you write the relationship W equal to F into S, F, you can see that it is given as 5 Newton, so you will be writing 5 here. The object is displaced through 2 meter, so you will be writing 2 here, and 5 to the 10, you will get the 10 joule. Okay, because the unit of the work, it is joule, so we have to write the joule. Okay, so in this case, what is the work done? It is 10 joule. So you have to just see what is the force and what is the displacement here. Now the next, if you consider a porter lift a luggage of 15 kg. Okay, what a porter is doing, he is lifting a luggage. How much is the weight? It is 15 kg from the ground and pulls it on his head. Okay, it is keeping on his head 1.5 above the ground. So how much he has lifted? 1.5 above the ground. What you have to calculate? You have to calculate the work done. Now in this condition, in this case, you have to write down the given condition. A porter lifts a luggage of 15 kg. So what is the mass here? It is 15 kg from the ground and pulls it on his head 1.5 above the ground. So the height, it is given, or you can say the distance from the ground, it is given as the 1.5 meter above the ground. It means this porter, it is carrying a luggage of 15 kg and is holding and keeping on his head, and from the ground, if you see the distance level, it is the 1.5 above the ground. So what you have to calculate? The work done. Now if you write the given condition, M equal to 15 kg, S equal to 1.5 meter. Okay, this is the distance given, or you can say the height from the ground, it is given as 1.5 meter. Now we know the basic formula, W equal to F into S. Now in the forces and laws of motion, we have considered the formula of the force, that is, it is the product of the mass and acceleration, F equal to M into A. But here we are not writing the A in the place, since we are in this, we are considering the gravity, so we are writing the M into G. Okay, so you can substitute the value F as M into G, and as we are writing as it is. So what is the F given? It is 15. What is the G? We are taking it as, it is given in the question that you have to take as 10 value. Okay, and the H or the S we can consider as a 1.5. So on solving you are getting the 225 Newton meter, and this Newton meter it is equivalent to joule. So what will be the answer? It is the 225 joule. Okay. So in this case you have to remember, now in the previous question directly the force was given. Now sometimes in the numerical direct force it is not given, they will be giving you the mass and the height or the distance from the ground. So that will be considered, because we know that according to the Newton's second law, F equal to m into g. So this value can be substituted at the place of F, and we can easily calculate the work done. Okay. So this both the numericals, these are based on this relationship W equal to F into S. And sometime if directly if the F it is not given, you can easily calculate by multiplying the mass and the gravitational acceleration. Okay. So we have to consider that what are the condition of work. The two conditions should be there. The force should be applied on the body and the body should get displaced. If the body is not displacing, it means the no work is done. Okay. Now work can do this following conditions. It can do the following work. It can the moving object can come to the rest, or it can produce the motion into the body which is rest, and it can change the shape of the object. And W equal to F into S, it is the product of the force and displacement. Okay. So you have to practice the numerical based on W equal to F into S.